All right, today we're going to talk about solving two-step equations. So when we're solving two-step equations, we are going to create a do-undo chart. So a do-undo chart is basically going to be on the left side. We're going to talk about things that they are doing to X, right, over here. And on the right side, we're going to talk about how to undo those things. And by doing that, we're going to use those inverse operations, okay? So our do first is going to be either an add or subtract. Are they adding or subtracting to the X, okay? And because it's an add and subtract, we will make sure that we check for our integer strategy, which is our positive negative table. And then our second step will be to check for multiplying or dividing. And again, if we're multiplying or dividing, we will use integer man for that step, okay? So make sure we're using our integer strategies as we are solving. So if that doesn't make sense to you, it will after we do these first couple of examples, all right? So before we get started, let's talk about how do I undo? How do I make the inverse operation? So last year we learned that inverse operations are just opposites. So what is the opposite of adding? Well, the opposite of adding is subtracting, so subtraction. Okay, so if they're adding, then we need to subtract to get rid of that item. And then if they're subtracting, well, then the opposite would be addition. Okay, so if they're subtracting, then we will add. And then the opposite of multiplying, remember multiply can be a dot, an X, or parentheses. If they're multiplying, then we will divide. That is the opposite, the inverse. Remember, division can be a division sign or it could be a fraction, okay? Cowboy and horse fraction. And then again, division, the opposite of division is multiplication. Okay? And again, remember multiplication, the dot, the X, or the parentheses. So those are our inverse operations. So now let's try to solve for number 1. So in example number 1, we are trying to solve for X, meaning we are trying to get X alone, okay, all by itself. And so we need to start by drawing a line down the equal sign, okay? Anything I do to the left side of the equation, I'm gonna have to do to the right side of the equation, okay? To keep things balanced, like a balance beam, we need the left and the right to have the same things done to it. So before we get started solving, I'm going to create my do-undo chart so that I don't make any mistakes. So first thing first, I'm going to say, okay, what adding and subtracting items are in my problem? Well, I can see here that what are they doing to X? Oh, they're adding 7. So on my do-undo chart, I am going to write they are adding 7, okay? And then the next thing I'm looking for is the multiplying and dividing. So I'm going to check and I'm going to say, okay, are they doing any multiplying and dividing to X? Yes, we learned that when a number and a letter sit side by side, that is actually multiplying. So I'm going to rewrite this as 4 times X plus 7 equals 19. So all I did was rewrite my problem so that instead of it being side by side, I actually put the multiplication symbol in there. And then on my do chart, I'm going to say, oh, they multiplied by 4, okay? So we have written down what they are doing. So how are we going to undo these things? Well, what is the opposite of adding 7? Well, the opposite of addition is subtraction. So I am going to subtract 7 from both sides of my problem to get rid of the 7. And then what is the opposite of multiplying by 4? Well, the opposite of multiplying by 4 would be dividing by 4. So I'm going to take my problem and I'm going to divide both sides by 4. So now I have instructions on how to solve. First, I'm going to subtract 7 from both sides. So I'm going to grab my pen and then right under this 7 to make it go away, to make it 0, I'm going to subtract it, okay? And then anything I do to one side, I have to make a matching subtraction 7 on the other side of my line. Over here, the 7's go away, because what is 7 minus 7? Well, it's 0. And then I just bring down my 4 times x. And then over here, 19 minus 7 is 12. Okay? So I have solved my subtracting 7 line, so I can check it off. And I did not need my integer table, my positive and negative table, because it was just a regular old 19 minus 7. Okay, so no real negatives there. All right, I'm not done solving because I still need x to be by itself. So I need to get rid of my times 4. The opposite of multiplying by 4 is dividing by 4. So I'm going to come and divide by 4 to make the multiplying and dividing cancel out because they're inverse, they're opposites. And anything I do to that one side, I have to do to the other. So those 4's cancel out. And now my x is all alone, just like we wanted it to be. And then I have to ask myself, okay, what is 12, my cowboy, divided by 4, my horse? If I needed to write it out, I could write it out long ways, 12 divided by 4, if that makes more sense to you. But regardless, 12 is the cowboy and 4 is the horse. So 12 divided by 4 is in fact 3, and that is my solution. I double checked, did I do everything on my do-undo list? Yes, I did. I did not need integer man because there were no negatives. 12 was positive and 4 was positive, so I did not need integer man, but I want to make sure and check. So I made sure and checked for both my table and my integer man to make sure I didn't forget anything. All right, now how could I check my answer? How could I make sure without a doubt my answer is correct? I'm just going to take my answer and plug it in. So I'm going to take x out and I'm going to plug in 3. And so what does it mean when a number sits next to parentheses? That means multiply. So what is 4 times 3? Well, 4 times 3 is 12. And then what is 12 plus 7? 12 plus 7 is 19. Does 19 equal 19? Yes, it does. I got that answer right. All right, let's try the next problem. Again, I see an equation. I see I'm solving for x, and it's an equation with an equal sign. So I know I need my do-undo chart. So I'm going to create my oops, I spelled it wrong. There we go. Okay, I created my do-undo chart. And we're always going to start by writing down what they are doing, and specifically what they are doing, adding and subtracting first. So they are subtracting 8. So I'm going to write that down. They are subtracting 8. All right, so what would the inverse operation of subtraction be? Well, that would be adding 8. So on my undo, I'm going to write adding 8, and those will cancel each other out. All right, and then finishing my do-undo chart, I look and I say, okay, what is with the x? Well, this time they are dividing. I know they're dividing because it looks like a fraction, and fraction means divide. So they are dividing by -2. So I'm going to write that in my chart. They are dividing by -2. So I have to ask myself, how could I undo dividing? What is the opposite of dividing? Well, the opposite or inverse of dividing would be multiplying. So I'm going to multiply by -2. Okay? So again, I double check, did I use the inverse on each side? What was the opposite of subtracting? Adding. Perfect. What was the opposite of dividing? Multiplying. Perfect. So now I'm ready to solve. Don't forget that when you are solving for adding and subtracting, you might need your positive negative table. And when you are multiplying and dividing, you might need your integer man. So I go ahead and draw those just in case. All right, I'm going to draw my line down my equal sign. Remember, your equal sign is like a giant balance beam. We want to get x alone on this side, so we have to start getting rid of stuff. Remember, what's the first thing we're going to do? We are going to we're going to get rid of the subtracting 8, and in order to get rid of that, we will add 8. So I draw my line across. I can't do it on one side or my balance beam or my seesaw gets off balance. So I have to do it on the other side as well. So what is 8 minus 8? Well, that just becomes 0. And then I can bring down my x divided by -2. My equal sign's still in the middle. And 10 plus 8 is 18. So I didn't need my positive negative table, but again, it's always good to check and make sure. So I did my add 8 on both sides. So now I'm moving on to my next step, which is going to be the multiplying by -2. So in order to cancel the division out, I'm going to multiply by -2 because the opposite of dividing is multiplying. And so the opposites cancel each other out. And all that's left over here is going to be my x. But we still have to do the same thing on both sides. So I'm going to come over here and multiply by -2 as well. And in this case, I am going to need my integer man because I'm multiplying with a negative. So my 18 was positive, my 2 was negative, so my answer will be -36 because 18 times 2 is 36. So that is my solution. I double check and ask myself, did I put my times -2 on both sides? Right there and right there. Yes, I did. So I can check off this step. Did I use my integer man when I needed him? Yes, I did. And so now how can I check myself? I can just plug my answer back in. So I'm going to take my answer of -36, and instead of x, I'm just writing it in that spot. I know I will need integer man because I am dividing there, so I'm going to go ahead and draw him right there. All right, what is -36 divided by -2? Well, that's going to be a positive 18. Positive 18. And then what is 18 minus 8? Well, that is 10. Does 10 equal 10? Yes, it does. And I have proven my answer. All right, guys, go practice solving two-step equations.